Okay, so then we touched on the rational root test the other day at the end of the lesson. So I want to make sure that we're good with this. So this is your guesses. So like for instance, what would be a smart guess when we set example 1 equal to 0? What's going to be a smart guess? 1. You're looking at the factors there. However, this number in front means that 1/2 could be an option. Because of that 2, if I were to use a half, it would end up changing the numbers to where we could get like 1/2 times 2 at the end, and that would give us a 1. So this number in front also dictates our choices. So first thing we're going to do is list our possible, we call our possible zeros, or our possible rational zeros. Rational means the type of number they are, fraction zeros. So if you have ax cubed plus bx squared plus cx plus d equal to 0, and it could be a 4th degree or 5th degree, it doesn't matter. So what we're looking at is your possible zeros are this: the factors of d, so whatever the last number is, over the factors of a. Those give you your choices. So the a is the first number, the leading coefficient. Okay. So if it's a 4th degree, it's whatever your constant is at the end. Okay. So these are your possible choices. And remember, we use plus or minus, so don't forget to do plus or minus, because negatives are a choice. The other thing I want to show you is Descartes' rule of signs. I'm gonna use, as we work example 1 together, I'm gonna show you what it tells you. Okay, it may be helpful, it may not. So real quick I'll just write this out, and then I'll show you how we use it on this example here. So whatever your function is. All right, so let's just take this one, and I'll show you how I'll know maybe how many positive zeros and how many negative zeros there are. So first thing, for positive zeros, here's what you do. Means like your solution's a positive number, right? So what you're going to do is this. First thing you do is, what are the number of sign changes for f of x, or less that amount, or less that number by an even amount. Okay, so it sounds confusing, but it's not that bad. So just look at this polynomial for example 1. What's the sign of the first number? Positive. What's the sign of the second number? Negative. So this is one sign change, because it went from positive to negative. But since it stays negative, the sign doesn't change anymore. So since there's one sign change for f of x, that means there's one possible zero. You can't go, you got to go less than by an even amount. Well, if you go 2 less than 1, you get a negative, and you can't have a negative number of choices. It's telling you how many positive solutions there are. So on this one, since there's one sign change for f of x, then there has to be one positive answer. So there has to be one positive number that's the solution, okay? All right, and then we do this for negative zeros. First find f of negative x. So just plug in a negative x real quick and see what happens. If I plug in a negative x, let's see what happens to the sign. All right, so when you plug in a negative to an odd degree, what's going to happen to the negative? Does it stay negative or does it turn positive? It stays negative. So this is going to become negative 2x cubed. Here, when I plug in negative x in for squared, it's going to become positive. So this stays negative 5x squared. A negative 5 times negative x is positive 5x, and then of course the minus 1 at the end. So how many sign changes do you see?
1.
More than 1.
2.
2. No sign change, no sign change. Negative to positive is 1, positive to negative is 2. So how many negative zeros there are? So you find f of negative x, which is a little awkward. You got to plug in a negative x. So the number of negative solutions are the number of sign changes or less that number by an even amount. Now, I'm going to be honest with you. I typically don't even mess with this. I just start testing. Because in all this time now, I could already plugged in a 1, and 1 might be the solution. But I'm at least explaining to you what it tells you. It's just a tool if you want to use it. So on this one, for this problem, we know for negative zeros, we're either going to have 2 or, all right, so because we got 2 sign changes, so there could be 2 negative solutions, or now subtract 2 from 2, you would get 0. So it's either 2 or 0 negative solutions. That's what this is saying. So if I cover up the 0, how many, 1 positive, 2 negative, how many does that add up to? 3. What's the degree of this polynomial? 3. Now, is it possible that we could have 1 positive and no negative? How? Imaginary, very good. 2 imaginary. Now your imaginary always occur in pairs. So just one last note, just make sure you know that imaginary solutions occur in conjugate pairs. Okay. All right. So we're going to work example 1 together. Hopefully we just plug in a number and we finish it. But they're going to ask you, like, what are the factors? They may ask you, how many positive solutions are guaranteed? You need to say 1. Otherwise, you're going to get into homework and you're going to be like, well, what's Descartes' rule of sign? Okay? And this is named after René Descartes. What else is René Descartes famous for? Don't say Descartes, okay? Act like you've been in Spanish class. What else is René Descartes famous for? The Cartesian plane, which is what you plot all your numbers and graphs in. The XY plane you use is called the Cartesian plane. It's named after René Descartes. Okay, that's extra. That's bonus cash. All right, so let's get started with this. So first thing we're going to do on example 1, I'm going to set it equal to 0. I know, first of all, there's how many solutions are guaranteed? 3. Now from this little sign test I did, I can see. I usually just do positive solutions. I don't worry about negative. So I can see the sign changed 1 time. So there has to be 1 positive solution. And then if you find f of negative x and see how many times that sign changes, 1, 2, there's either 2 or no negative solutions. What are my possible zeros? So let's list that first. So it's the factors of what first? What do I put on top? The factors of 1. What are the factors of 1? So always put plus or minus. So plus or minus 1 over the factors of 2. What are the factors of 2? So you do plus or minus 1, plus or minus 2. And what you're going to see is now we have 4 choices. Because 1 over 1 is still just plus or minus 1. But 1 over 2, that means a half, and negative a half is a choice. So I really don't want to do synthetic division with that. Okay? All right, so now what? So now we're trying to solve for x. So now what do you have to do? How did we solve? What was our whole lesson on Friday? This was Friday's lesson. Please tell me you remember what I did the whole time on Friday. Yes. And what are you hoping your remainder is? If your remainder is 0, then can you completely factor the problem? More than likely, yes. All right? You have to be a good what? Guesser. What are your guesses?
Plus or
1,
or
negative 1, 1 half, negative 1 half. All you need is 1 to work, 1 answer. And all this is just telling you, look, you're gonna have one positive answer. So I might try 1 1/2 first. That's probably what I would try. Because it's telling you, you're gonna have one. Here, you don't know that you have a negative answer. You could. So you could try -1 and see what happens. That doesn't look good there. So it's probably gonna be a half. So I would try 1, or I can see 1 doesn't work. How do I know 1 doesn't work? How do I know 1's not a solution? What does it mean to be a solution?
It has to, the remainder has to be 0.
Yeah, but in terms of the equation, what does it mean to be a solution?
It
Means that if I plug that number in, our answer should be what? I can look and see that if I plug a 1 in, I ain't gonna get 0. So 1 is not a solution, so don't even try 1. So therefore, if I know there's one positive answer, and it has to come from here, what's the only number I can try? There you go. Now you know 1/2 is a solution. It should be. Go. You got it. You'll get a quadratic, then you factor the quadratic. And then once you get done with example 1, set example 2 to 0. So let me erase up here. We've got this in our notes now. So for example 2, I'm just gonna go ahead and get it ready. Tell you what you need to do. Part A, list the possible rational zeros. From Descartes' rule of signs, I'm just writing example 2, what I want you to do. How many positive solutions and how many negative solutions? And then part C is solved. Do part A first though. And running out of video. A little bit of pain using a fraction, but if it gets you a solution, then you got to use it. I'm going to erase this Descartes rule of signs. Don't get too caught up in this. If you have trouble, it's not that important. I mean, the most important thing is that you can solve this analytically. I'll help you with it. We'll do, after you do a couple of examples, I think you pretty much get it. All right, so let's catch up and see where we're at. So I know from Descartes' rule of signs, I should have exactly one. There we go. I needed a good marker. Positive solutions. I should have exactly one, not the number 1, but the one's positive solution. So I can see 1 is not going to work. So I'm going to try 1/2, and I'm going to do my synthetic division and see what happens. So 2. 1/2 times 2, we get what? 1. What goes here? All right. 1/2 times -4 is -2. All right. Well, maybe I lied. What did I do wrong here? Did I write the wrong problem down?
-1/2.
What's that?
I got it with -1/2.
Yeah, but there should be one positive. One sign change means there's going to be exactly one positive solution. It could be, it should be rational. You said -1/2 work? All right. Then there should be 2 negatives then. But it still should give one positive. I wonder if it's just irrational. Read this real quick. Real zeros, okay, yeah. So then when you did your quadratic, you should have got a quadratic, you should have used quadratic formula.
Yeah.
There's your, okay. So 1/2 won't work. So we try, you said you tried -1/2? 2, -5, -5, -1. Let's see. All right, so 2, 1/2 times -2, -1, -6, 1/2 times -6, 3. That's -2. -1/2 times -2 is +1. Remainder is 0. Okay. So at this point, good. So you used your -1/2. But do you see why these choices are helpful? Do. All right. So you do x plus 1/2 as a factor. What's your other factor? 2x. What? 2x squared minus 6x minus 2. Well, you can try to factor this, but this is not going to factor. So anytime you get down to a quadratic, so now we know we can set each of these to 0, so we know our -1/2 is a solution. So how can you always solve a quadratic if you can't factor it? Quadratic formula. So -b. I was golfing with somebody the other day, and like they're probably in their 30s, and they had this formula memorized. I said, I don't remember how to use it, but I at least memorize this. I said, good. Okay, so -b. So let's see, -6 plus or minus the square root. 6 squared is 36. Minus 4, a is 2, c is -2. All over 2a is 4. So let's see, what does this end up equaling? 8, 16 and 36, 52. So not very pretty under the radical. Trying to think, is there a perfect square we can take out of 52? It's 26 times 2, but it's 13 times 4. So, all right, that's 52. So you're going to need to simplify your radicals on the side here. So let's see, square root of 52, whoops, is the same as 4 times 13, right? I just did 26 times 2, and then I did 2 times 13 for 26. So the 4 goes in front as a 2. So -6 plus or minus 2 on the square root of 13 over 4. You could break that up, and don't forget about your -1/2. There's your other answer. So let's count. -6 minus 2 square root of 13 over 4 should be negative. -6 plus 2 square root of 13 over 4 should still be negative. Oh no, that one should be positive, and there's your negative. So you should have 1 positive answer, 2 negative answers from Descartes' rule of signs. So -6 plus 2 square root of 13 should come out positive. Okay.
Wait, would the 6 be positive? Because,
Oh, did I mess up somewhere?
Negative.
-b, yeah, so plus 6, yes, that's right. So here's 1 positive, 1 negative. Yeah. Makes sense. Sorry, -b. All right. Got it. And then what could I cancel out of this? 6, 2, and 4. What can you cancel? 2. You should get 3 plus or minus the square root of 13 over 2. 3 plus or minus the square root. 1 positive, 1 negative, 1 negative. There you go. All right. Okay. So let's look at example 2. So list all the so here's what students do. They start trying to list the answers. That's not what it asked for. It's saying, what are the possibilities? List the possibilities first, and we'll see how many positive solutions, how many negative we could have using Descartes' rule of sign. So let's at least do that together on example 2. So let's look at example 2. All right. Part A. First, you list the factors of what? Yeah, in this case, D is what? 6. So what are the factors of 6? 1, 2, 3, and 6 over the factors of what? A, which is what? What are the factors of 3? So I like to leave it like this, but I think they're going to want you to expand it. So you're going to write out basically 1, 2, 3, and 6 divided by 1 is still just 1, 2, 3, and 6. You've got 1, 2, 3, and 6. But then you need to divide by a third. So 1/3, 2/3, you could put, don't put 3/3 and 6/3. Why not? That's 1 and 2. So you could add 1/3 and 2/3. Those are going to be the last ones I'm going to test, right? Because I don't want to deal with fractions. It's a pain. So I'm hoping 1, 2, or 3 will work. Okay? All right. Now, let's just look at Descartes' rule of sign. So let's see. How many times does the sign change? 1, right there. This is not a sign change. What else? Negative to positive. So how many times? 2. Does everybody see there's 2 sign changes? From positive to negative, then from here from negative to positive. So on that tells us there's going to be 2 positive solutions or 0, because you take however many it was or less that by an even amount. Had it been 4, it could have been 4 positive, 2 positive, or 0. So you need to know there's either 2 positive solutions or no positive solutions. Okay? All right, so let's try the negative. So I'm going to just plug in a negative x real quick. Oh, sorry, I'm still on part B. So if I plug in a negative x, it's going to stay 3x to the 4th. So all my odd ones will change the sign. So that'll become plus 11x cubed minus x squared minus 19x plus 6. So let's see. How many sign changes do you see? 2. 1, 2. So again, now there's 2 or 0 negative solutions. All right. What does your gut tell you is going to happen? What do you feel is going to happen? How many total solutions are there? 4. How do you know there's 4? 4th degree. What does your gut say? You have to do that, but what do you think is going to happen? Like, is it possible you could have 2 positive and no negative? Yeah. Yes, how? Yeah, do you think you're going to have imaginary? I don't think so. I don't think so. I think you're going to have 2 positive and 2 negative, which adds up to how many? 4. So when you're testing, be looking for 2 positive solutions and 2 negative solutions. So you're going to try both. Okay? All right. So that's all just help. Now for you, now it comes down to being a good guesser. Now, Austin, what did you say? We're going to have to guess twice. Why? Why? Right. So once you get something to work, you're going to get an x cubed factor. You got to get something else. All right. So now see if you can solve. Go ahead. Now here's all your choices. Now you got to be a good guesser. If you plug in a 1, you're wasting time. You should already know that 1 doesn't work. I've already taught you how to do that. If you have all your answers, raise your hand, I'll come and check it. Put my mask on.
Oh, no.
Oh, you still?
Yeah.
Okay. There you go. You're doing almost. You got two to work now, and then once you get down to a quadratic, you can always solve it. Quadratic formula. Oh. Good. So now, if you use quadratic formula, you got that. Now, I didn't get one working. One's impossible.
That's why you use.
So negative 1 and 2.
Yeah.
But this you can answer. Right, so add that, and then about, so you can write the answer. You see what I'm saying? Yeah. Yeah, just write it. I got you. Yeah. There you go. Good. So do you use quadratic formula? Do you, right?
On the second one, yeah.
Yeah. But it tells you if they come out like that you could factor it. Okay. I usually flip flop. Like I usually do this one first, 1 and negative 1. If that doesn't work, then I do 2 and negative 2. Why did I say 1? How do I know 1 doesn't work? What does it mean to be a solution? This is what I asked earlier in class. A solution means if you plug in for x, right up here, if you plug in for x, well, you should get what answer? 0. Well, I know when I plug in a 1, it's not going to change any numbers. So I can see if I plug in a 1, if I start adding everything up, it's not going to add up to 0. So 1 is not a solution. So don't try 1. Okay? So then I would try negative 1. Negative 1 would be my first choice. Or I would try negative. And then after that, if that doesn't work, then I'm going to do 2 and negative 2. And I just kind of, that way I kind of can cross it out as I go. So now I'm going to try negative. Get on these markers. So I'm going to try negative 1. So let's see. 3, negative 11, negative 1, 19, and 6. So 3, negative 3, negative 14, 14, 13, negative 13, 6, negative 6, remainder is 0. So what does that tell me? Not x.
X plus 1.
X plus 1 is a factor, and x equals negative 1 is a solution. So I have 1 out now. So now I know x plus 1 is a factor. What else do I know is a factor? 3x cubed minus 14x squared plus 13x plus 6. So now I've taken this and I factored it to here, but what's the problem with this? I don't know how to solve that, so I gotta do it again. I gotta go through this whole process again. Notice it's still a 3 at the front and a 6 at the end, so it doesn't change my choices. Had one of these numbers changed, then your choices would change. Okay, you always make your choices there. So now, I've tried 1. If 1 didn't work before, if 1 is not a factor of this, then it certainly is not a factor here. So if something didn't work before, there's no chance of it working again. So, all right, I did negative 1. It could be a double root, but I'm going to move on and try, what's the next number? 2. And then if 2 doesn't work, I'm going to try negative 2. All right, so let's see. So I'm going to try 2, but now I'm working it here with this one. So use my 2. 3, negative 14, 13, 6. So let's see what happens. 6, 12. I can go ahead and stop. Why am I doing that? Why am I stopping now?
Because you're trying to add up to a really big number.
Yeah, I need to get what number here?
6.
Negative 6. There's no way. That's negative 2. That's negative 4. That's 9. I'm not going to get. Yeah, or did I make a mistake or what?
The first one.
What? Oh, yeah, I'm stupid here. Let's see if does that change anything? Sorry. I don't know why I'm making mistakes there. That's right. Andrew's saying you're being an idiot. When you bring down the 3, it's a 3, not a 6. So let's retry again. So now it might work. Maybe, maybe not. Let's see, 6. Now that's -8. So now is there a chance? Yeah. So don't do what I did. If you do the wrong math, it ain't gonna work. -16. So now I feel better about it. Yeah. 13 and -16 is -3. 2 times -3. Okay, -6. So yeah, if you do it wrong, that's not gonna help you. All right, so now what do I know? So now we still got our x plus 1. What does this tell me is a factor? X minus 2, what else is a factor? All right, -3. Okay, now, notice I have one negative solution and one positive solution. So from over here, that's why we did all this. You either have to have 2 positive or no positive. And you either have to have 2 negative or no negative. So since I have one of each, there has to be one more positive and one more negative sitting in here. Okay, that's all that it tells you. I really don't think Descartes' rule of signs is that helpful. Just kind of reinforces what you're doing. Okay, and this will factor. So when I get to my quadratic, I can either do what you did, quadratic formula. You can always do that. Let's simplify it all the way. I can see if it factors, it's got to go 3x and x. How do I know it has to go 3x and x? Yeah, it's 3x squared. The only way I can get 3x squared is if I have 3x and x first. Then I look at last. So I know now, so again, what I'm doing is I'm doing reverse FOIL. I need 2 numbers here that multiply to give -3, and when I do outer and inner, I got to get -8. So I can see that this -3 needs to be here, and a +1 needs to be there, and it just comes from experience. All I'm going to do real quick, if I do outer, I get -9x. If I do inner, I get x. If you add those up, you get -8x. So it's just from factoring the quadratic, okay? If you don't like factoring, you can use quadratic formula. There's all my factors. Now here's my solutions, -1, 2. What's the solution when you set 3x plus 1 equal to 0? Yeah, and what's the solution when you set x minus 3 equal to 0? 2 negative, 2 positive, which is guaranteed by Descartes' rule of signs, and that's all that is the purpose for. Notice, did all of our answers come from here? No, they didn't. Let's see, -1 is not up here. 2, -1/3, 3. So I'll ask again, did all of our answers come from there? So they're all rational zeros. It won't always happen like that, because if you get, like in the last problem, I got square root. These are just giving you choices. They may not all, you may get imaginary solutions. If you get imaginary solutions, those are not there. Okay. I'll give you one more to solve, and then we'll stop there and we'll just work on the homework the rest of the time. So here we go. One problem. I don't care how you solve it, just get it solved. Okay. Let me really solve this. At least list the possible zeros. I would do that. You don't have to do Descartes if you don't want. It's probably good practice anyways. Might be out of the screen there. Let me move over. So set this equal to 0, x to the 4th minus x cubed plus 2x squared minus 4x minus 8. Okay, how many total solutions are guaranteed by fundamental theorem of algebra? 4, all right? I would list my possible choices and then go from there. If you can solve this one, and then we'll just solve. Make sure you can solve it. Find all solutions. How could you cheat? a way to cheat.
You could plot it on the.
Yeah, plot it on your calculator and see where it looks like it crosses. They're gonna tell you to do that in the homework too. They're gonna say, use a graphing utility. So if it looks like it crosses near 17, I'm gonna use 17. We know it's not 17, but I'm just saying that. If it looks like it crosses near 3, I'm gonna use 3. Okay? Don't forget that double roots could happen. I don't know if it happens on this, but you could have double roots. One have a chance? No, no way, right? Don't waste your time with that. The numbers don't add up to 0, so you know 1 is not working. Some cubics are factorable, so you could get a cubic that factors, so don't throw that chance out. All right, at least help me out here, catch up a little bit. What are my possible choices? Well, plus or minus 1. Plus or minus 2.
Plus minus 4.
And plus or minus 8. We don't divide by 1, right? So just leave it like that. There's all your choices. All right. Now, real quick, if I want to know how many positive solutions, just look at your function and count how many times does it change sign. How many times do you see? Positive to negative is 1. Negative to positive is 2. Positive to negative is 3. So that means for positive solutions, there's going to be 3 or 1. Because you just start going down in an even amount. So there's either 3 positive or 1 positive. For negative, here's all I do real quick. The odd ones are the ones that you would change the sign. So on the negative, the way f of negative x is, leave your even ones alone and change the sign on your odd ones. All right, so I went to my two odd ones and I changed the sign. That's what f of negative x is. And notice you have only one sign change. So that's telling me that for negative, there has to be one negative solution. So how could there be one positive and one negative? Imaginary, two imaginary. Imaginary doesn't count as positive because it's not a real solution. So there could be one positive, one negative, and two imaginary. Or there could be three positive and one negative. So we know it's got to add up to 4. So that's all. You don't have to know that to work the problem. You can still just work the problem. So I haven't worked the problem, so I'm going to guess, and I'm going to try 2. I know 1 doesn't work. I'm going to try 2. Just because of the 4 and the 8 and the 2, I just like 2. Make sure I do this right, Andrew. Chosen wisely. Now, look how it goes 1, 1, 4, 4. That's factorable. See? 2 times 4 is 8. Remainder is 0. That you can do by grouping. See, now I know I get x minus 2, x cubed plus x squared plus 4x plus 4. See, once I see that this is the same ratio, 1, 1, 4 to 4 is 1 to 1, I know I can do factor by grouping. So you don't need to keep doing rational root tests if it will work, if you can do factor by grouping. So I'm going to just do factor by grouping. Let's see, what goes out of the first group? Leaves me with x plus 1, so that tells me negative 1 would have worked. And then what comes out of the second group? 4, that leaves me with x plus 1. So what can I factor out of the whole thing? All right, so now you got x minus 2, x plus 1, x squared plus 4. Okay, so now we can see 2 of our answers. So if some of you tried negative 1, you should have got negative 1 to work. All right, now how do I solve x squared plus 4? Well, you could use quadratic formula, but why? Just solve for x. The 4 goes over, x squared is negative 4, then what do? X is plus or minus the square root of negative 4, and we've studied complex numbers before. What is the square root of negative 4? 2i. So look at your answers. Oops. 1 positive, 1 negative, 2 imaginary, which was guaranteed. Notice 2i and negative 2i won't show up here because this is called a rational root test, not imaginary root test. So those weren't choices, but those choices helped me to solve it. Okay? You would just, this is all your homework is. All right. You got the help me button and all that. Any general questions about the process?